In this video, we're going to look at how to apply kinematic equations to vertical motion. Now, we're not looking at trajectories where it's going at an angle, just straight up and down. So in this example, it's a volcano shooting a blob of lava upwards. We know the initial speed is 23.2 meters per second. We want the maximum height. And we'll go through these A, B, C, D, and E nice and slow. Now, one thing to remember is for these problems, it's usually better off to split them into the up process and then the down process, or the down half. It's much easier to think about it half and half than to try and do everything at once. It is possible to do them simultaneously, but most of the time it's better off to think about them going up and down. Now, going up, it'll reach a certain maximum height. We'll call that y. We know it's v initial. It's 23.2 meters per second. And another thing we know is gravity. Acceleration is always negative 9.8 meters per second squared, pointing downward. We don't know anything about the time. Now, we will solve for that in a little bit, but we don't know anything about the time yet. So probably our best option is the time-independent equation. Now, we knew the initial, and at the certain point at the tippy top there, it's going to stop. When we throw things into the air, they slow down because of gravity. So V final will be 0. That'll make life a lot easier, because then I can show you the algebra over here. We have negative v initial squared over 2y. Multiply both sides by y and divide by a. And we get that formula. And please feel free at any time, pause the video if you want to write stuff down. I'm not going to go at the same pace I would if I were lecturing in a class because I want to cover some material. But certainly you can pause the video and write your numbers down, or watch it again. So I write my numbers down, write my numbers in, and the negatives will cancel. That's exactly what we want. We get a maximum height of 27.5. Now, part B said, well, how long does that take? So we're going to solve for time up, t up. Not time down, not just yet. So V final is 0. So a little bit of algebra, multiply both sides by t, divide by a. And we should be able to get the time up, no problem. 2.37 seconds. Now, there is something that's really nice about these problems. Since we're worried about it going back to the same level, time down will also equal 2.37 seconds. We are neglecting air drag here. Air drag would have an effect, but we neglect that for Physics 1. But also, please remember, that's only if it returns to the exact same level. It does not work if it's going like off a building, which we'll see. We will see problems like that. They're not terribly harder, but we'll see those in a little bit. So to get our total time, all we have to do is double that. 2.37 times 2 is 4.74 seconds. So we're well on our way. Now it'll want the final speed. And that's a unique question because it'll start out at 0 and then it will have some final speed. But let's just focus on the time down, not the total time. We're only looking at this half of the process. You could almost think about it as like panels in a comic strip. You know, the boxes in a comic strip or a comic book, where we're only going to look at the process where it's coming down. That way, V initial is 0. Let's multiply both sides by T. And see what we get. We get negative 23.2 meters per second. Now, the last part of the problem, and let me show you it again. Just have to flip back up here. Sorry about that. Is when was it at 10 meters? And what was the maximum height? 27.5. So let's draw a picture of that. Get down to the slide we need to. And see what's going on. So here's our volcano. It's going to go up to a height of 27.5 meters. Then it'll come back down, and here's the lava and stuff. And we're interested in when was it at 10 meters? Well, it'll pass 10 meters on the way up, and it'll pass 10 meters on the way down. And it did have an initial speed. I believe it was 23.2 meters per second. Okay, well, let's use the position equation, and we'll set the top of the volcano. We'll make that y initial and make that 0, because at least that'll cancel for us. 10 is y final. We want to know when is it at 10 meters. But it had an initial speed. It has an acceleration. So you may notice we have t and t squared in the same equation. Now, all I did here, and I left out units just because I think the problem's complicated enough as it is without units. So 1/2 of negative 9.8 is negative 4.9. Let's see what I'm going to do, or what we're going to do. Let's add 4.9 t squared to both sides and subtract 23.2 t. I want to get everything all on the same side, and I'll tell you my preference is to have the one with the t squared positive. And I've had other students tell me that over the years, that that's the way they prefer to do this. So look what we have. We have something a times t squared plus b times t plus c, and the equation is equal to 0. Doesn't that look like the quadratic formula? Where a is 4.9, b is negative 23.2. Be very careful about your positives and your negatives. They're important. And c is 10. So let me remind you, it's negative b plus or minus b squared, or square root of b squared minus 4ac, all over 2a. Oops, I forgot my c there. Now, I'm not going to go through every algebra step here, and this is what t will end up being equal to. So it'll be, now the negative of negative 23.2 is 23.2 plus or minus square root negative 23.2 squared, and that'll square out, minus 4 times 4.9 times 10, all over 2 times 4.9. And this will take some time. You know, I understand quadratic formulas take some time. We wouldn't have them on every single problem on a test or an assignment anyway, but you might see one. So when you do all that, you do get two numbers, and luckily they're both positive. If one was negative, we would have made a mistake, because you can't really have a negative time. So 4.8 seconds and 4.26. And that kind of makes sense, because it'll be 0.48 seconds on the way up. Then on the way back down, it'll pass the 10 meters at 4.26 seconds. And feel free to pause the video anytime you need to copy things down. Now that one took a while, I know that. So let's do one where we're on a cliff and it doesn't return to the same level. So let's draw a picture and see what's going on here. So the cliff is at 15 meters above the ground. And we're going to throw a rock straight up at 10 meters per second. It's going to reach some high point and then fall down to the bottom here. You can do these problems in the reverse way too, where you're on the ground and you throw the rock back up on the cliff. So let's get the maximum height and see what we can do. Now remember, we think about these as the going up process, or the going up half, and the going down half. So at the very tippy top, V will be 0, won't it? Because it has to turn around. It's not going to keep going forever. So our best bet is time independent. And the V final will cancel. So then we can multiply both sides by y and divide by a. Or you could, if you're really good with your algebra, you're just switching the a and the y position. Then we start to substitute. We get 5.1. However, there's something we have to remember. And let me change the color because I think it'll be easier to see it in another color. Oh, we'll go with blue. That 5.1 is in here. That's from where we threw the rock up to the tippy top. Well, on the way back down, it has to go more than 5.1 meters. 5.1 meters would be if we caught it, at the top of the cliff. We have to add in the 15 meters that we started with. This rock will actually fall when it goes all the way to the ground 20.1 meters because we were already up on top of this hill or cliff, whatever it was. Now let's get time up. And we can get away with using the definition of acceleration, so it's not too bad. Remember, on the way up, the V final will be 0. And we'll multiply both sides by t, divide by the a, or just switch the t and the a. Like I said, if you're really good with your algebra, that should be not a problem. So they told us V initial was 10. Gravity's 9.8. Luckily, the negatives go. And that's 1.02 seconds. That's time up. However, remember, on the way back down, it has to fall 20.1 meters. It has to fall much farther. So the time down is going to be a different number. And our best bet is the position equation. I know sometimes students don't like the position equation, but it's going to help us. But we have to be careful where we set things, where we set our y's. Let's make V initial 0. You say, but it was 10. True. It was 10 when we threw it from the cliff, but we're only looking, just like I said, think about the boxes, the panels of a comic strip. We're only looking at the way back down. We're not looking at the going up process. So that's good because that'll be 0. Now we have to pick y initial. Oh, let's pick y initial as the 20.1 and y or y final as 0. So then that's going to be 0 too. So I think you can see my equation. Y initial was 20.1. V initial t will become 0, and we'll eventually just get rid of that. Is 1/2 negative 9.8 t squared. So If we move the 20.1 to the other side, the negative sign eventually luckily goes away, because you can't have a negative time. That doesn't make sense. So let's see what we can do. 20.1, well, that's close to 20. 4.9 is close to 5. 20 divided by 5 is 4. Square root of 4 is 2. And yeah, we get 2.03. So just estimating like this, we can get a really good idea that we're in the right ballpark here. And it makes sense. The time down is longer. In fact, it's almost twice as long. Just about twice as long, but it had a lot farther to fall. And let's see what we need to calculate yet. Oh, we have another thing. We have to do the velocity as it hits the ground. Well, now we know the time down. Why not just use it? The initial is 0. Because we're only focusing on the way back down. We always try to split these problems into the up process and the down process. So V final is AT. Multiply them together. And you're going to see that this is about twice as much as the 10 meters, right? Because that's pretty close to 20. But it's negative. The reason it's negative is because V final is going to be pointing downwards because it's hitting the ground.